Okay, today we're talking about word reactions. So this time, the first thing we have to do is first write formulas, and then we can balance using coefficients. So you're going to need your reference tables to the periodic table, and here we go. Zinc, lead 2 nitrate. So that's lead plus 2. And then nitrate is a polyatomic, so reference table E, NO3 minus 1. So seeing as that is not neutral, we're going to crisscross. And so NO3 parentheses, 2 down there. Yield means arrow. Now that zinc is in a compound, I need to figure out its charge. So that's a plus 2. Nitrate is a minus 1. So got to crisscross. Put that thing in parentheses. 2 down there. And lead by itself. Okay, so we look. If you still need to do the scorecard method on a separate sheet or cram it in there, that's fine. I see that zincs are good. I see that leads are good. And we have 2 nitrates, which is 2 nitrogens, 6 oxygens, both sides. So I'm actually good. I can move on. Aluminum bromide. So aluminum, which is a plus 3. Look it up on periodic table if you're not sure. Bromine is a minus 1. So let's crisscross, and we get AlBr3. Your final formula should not include any charges, so make sure that's not there. Plus chlorine. Careful. Chlorine is a Hofbrinkel or diatomic element when it's by itself, so Cl2. Yield. Aluminum chloride. So, got to crisscross that. Cl3. And bromine, Hofbrinkel, so diatomic by itself. Okay, so I know that aluminums are good, but bromines are not, and chlorines are not. So I see I have 2s and 3s for both of those elements. So I need to come up with a common factor of, or multiple of 6. So for bromine to have 6, I'm going to put a 2 here. That makes the aluminums have 2 and bromines have 6, so I got to put a 3 here for 6 bromines. And now I need to put a 2 here because that adjusts my aluminums. It also makes chlorine 6, which is what I want, so I'm going to put a 3 here. That's a 3. Okay, looks good. Sodium phosphate, Na plus 1. PO4 minus 3. So that is not balanced. So let's crisscross. And we'll do Na3PO4 plus calcium chloride, Ca plus 2, Cl minus 1. I'm finding those charges on periodic table. So if you're wondering where am I getting them, that's where I'm getting them. And I'm doing it fast because I've been doing this for a few years. Yield, calcium phosphate. But remember, I already looked up those charges, so I should know. Ca is a plus 2. Phosphate is a minus 3. So when I crisscross, I'm just going to do this. I just skipped a step. You didn't see me writing in the charges, because I remember them from the reaction sign. And sodium chloride, plus 1, minus 1. Okay, so I see that this needs coefficients. Let's go with pink. And again, you know, you just kind of go and just do stuff. So I don't know. Calcium needs a 3. And again, there's no right or wrong way to do this. I'm going to choose calcium first. So calcium has a 3 on this side, on the left, and 3 on the right. Chlorine needs to be 6. So I got to put a 6 here. So then I would need to put a 2 here to get 6 for sodiums, and then I'm good. Now remember, you can always do the scorecard with the Na and the, you can do that. I just know that I don't need to do that right now. Potassium chlorate, K plus 1. And then chlorate is ClO3 minus 1. So you know what? I don't need that. ClO3 is good. When heated, you could say plus heat, yields potassium chloride, plus 1, minus 1, and oxygen, which is O2 because it's diatomic. Okay, so I see that my oxygens are not balanced. So I've got a 3 here and a 2 here, so we got to come up with that common multiple of 6. So I'll put a 2 out front, and then I'll put a 3 here. So that takes care of my oxygens. And then I need to put a 2 here to balance out my, that 3 is ugly. 3. My KCLs. Aluminum plus hydrochloric acid, reference table K if you didn't know it, HCl, nothing to balance, it's already ready, yields aluminum chloride, so Al plus 3, Cl minus 1, so that's going to be AlCl3, and hydrogen gas, so that's diatomic when it's by itself. So we're going to need some help here. Okay, chlorine, I need to do, let's see, well, I'll put a, I'm thinking, well, let's just do this. That's not going to work. See, I already did that, and it's not going to work because chlorine can't get to 2. And if I did this, I can't, that won't work because of my products. So I need a common multiple of 2 and 3. How about I go with that 6? So if I want a 6 here, then I could put a 2 here. So my chlorines are 6 and my aluminums are 2. So I'd throw that there. And then I need 6 hydrogens, so I'll put a 3 here. Now I know this isn't like great because the way my brain works might not be the way your brain works, and the way I'm seeing things might not be the same process, and that's okay. You don't have to do it in the same order I do. As long as you get to the same final result where everything is balanced following the law of conservation, you're all set. Calcium hydroxide, plus 2, minus 1. So we're going to crisscross, and we're going to put that OH in parentheses. Phosphoric acid, that's on reference table K. So you just copy it right down. Don't need to do any changing. Yield calcium phosphate. So calcium is a plus 2. Phosphate is a minus 3. So let's crisscross. Put a 2 there. And water. All right. There's a lot going on here. Lots of H's, lots of O's. So maybe I should figure out maybe I'm not going to worry about H's and O's just yet. I'm going to work about my calcium. So we'll start there. We'll start by putting a 3 here. So now my calciums are 3. That's good. All right, now the phosphorus. Okay, phosphorus, that needs to be a 2. See that? So I'll just do that. And so now, let me get rid of that. Let's see what's going on with the rest of them. Because there's H's everywhere, there's oxygens everywhere. I worry about the other elements first. Okay, so now let's talk reactants. Let's talk the left side. Let's count up our oxygens. We have 2 and 3, 6 oxygens there, and then 4 and 2 is 8. So that's 14 oxygens on the reactant side. Right now we have 8 and 1 is 9. Okay, that's not going to work. Well, there's so much of that. How about some hydrogen action? How about we look at that? So then for hydrogen, we have, again, we've got the 2 and 3, so that's 6 plus another 6 is 12. And so there's no hydrogens here, so I got to worry about hydrogens right here. How would I get 12? I'll put a 6 there. All right, now let me clean this up. Now, let's worry about oxygens. Now I have, how many? I had 14 on the left side, reactant side, and now I have 6 oxygens from this, and then I'm there. 8 and 6 is 14. Again, kind of messy sometimes, but there's no right or wrong way. Copper, sulfuric acids on reference table K. Yield, copper Roman numeral 2 sulfate, so copper plus 2. Oh, so I don't need any crisscross. Plus water, plus sulfur dioxide, that's Greek naming system. Okay, so where to begin? Coppers are good, sulfurs are good, hydrogens are good, but oxygens are not. There's tons of oxygens all over the place. So on the left or the right side, I've got 4 and 1 is 5 and 2 is 7. So I got to do something with this water because I need an even number of oxygens, and the only way to do it is to put something right here. So how about I just try a 2? Let me get rid of this to clean this up. So now let's talk about the oxygens. Oh, and that was a 4. Oops. So now we've got 4 here, plus 2 is 6, plus 2 more is 8. So how would I get 8 oxygens on my left side? I'd put a 2 there. That also takes care of my hydrogens because now I have 4 hydrogens. So that's good. Last one, hydrogen plus nitrogen monoxide, Greek naming system, yields water and nitrogen. Okay. Nitrogen, I see that. So then I would need 2 here to get my oxygens good, and then I would put a 2 here to get my hydrogens good. Okay, if you have questions, let me know. And remember, you don't have to do it exactly the same way as me. You just have to get there somehow. Thank you.